Here's our agenda for today. There are really three main topics in AP Calc AB. That would be limits, integrals, and derivatives. And integrals and derivatives really make up the majority of the tests, especially in AB, and a larger majority of BC now as well, that the exam format has changed. And it's important to know that most of the time when you're working to figure out a problem, you're most likely going to need to apply a derivative or an integral somehow, unless it's a limit problem. And even then, you could end up having to use L'Hopital's rule, so you still need derivatives. You just need to make sure you know when to use each and what it means when you're using it so that you know exactly when you see it the next time how to apply what you know. Okay, the practice problems we're going to be doing are from old AP exams, and they're from the free response question part of the exam, and they are in the calculator section. So if you have your calculator, it would be good to get that out and keep it with you so you can work along with the problem. I do have the answers, and I have my calculator out here, so if you don't have it, then that's okay. But if you do, it'll be good to have. So just one more review of the changes we know so far. In general, we know that the AP test is going to be online, and it's going to be 45 minutes, something you can take at home. There's going to be two test dates, one on earlier and one later on when they usually are. They haven't really talked much about the layout yet. They said that they will be, a College Board said they will come out with the layout on April 3rd. So keep an eye out. We'll be updating here. And we do know that because we only really got through 75% of the school year, AP took off about 25% of the material. For AP Calculus AB, that meant Unit 8 is no longer on the AP exam. For AP Calculus BC, that meant Unit 9 is no longer on the exam and some of Unit 10. And again, if you click on that link that I put in the chat, you can see exactly which units will be on it. Unit 8, which is still on the BC exam but is not on the AB, is about like discs and washers, cross sections, average value, applications of integration. Using integrals with velocity and acceleration. Most of anything you did that was 3D graphing, that is in Unit 8. So that's no longer on the AB exam, but it will be on BC. Okay. Some relief, I hear. Okay, so let's talk a little bit about derivatives. Let's start there. Do we need to know? This is for BC. I don't believe that is one of the sections that is still on there, but I can check and get back to you. I'd want to look a little bit more into the exact format of each section before I could say definitely yes. So I'll write down your question and hopefully we can answer that for you soon. Okay, so I added a nice calculus meme for you here just to lighten the mood of all of us, as someone said, suffering of AP and having to learn it all online. You guys are doing great and you're doing awesome for being here. So let's start off by talking about what does it mean to interpret a derivative? When I say interpret a derivative, what am I asking you to do? When you read the words interpret, can you think of some other descriptive words that might come to mind besides interpret? Good, Perla, you hit it right on the nose. So explaining context is a really good way to explain that. To interpret something means to understand what it means in the context of your problem. So most of the time when we're talking about derivatives or in interpreting derivatives, it's going to be mostly in free response questions, but there are some multiple choice questions where they might just give you a derivative and ask, how would this apply to this situation? So we're defining it, we're explaining it. There's lots of different words we can use. And then what about some other words we can use to describe derivatives? What are some other words we can use? Slope, great, slope is a good one. Rate, awesome. Good, rate of change is great. Okay, so some words that I had used are slope, rate of change, velocity, and speed. And just a review, do you guys know the difference between velocity and speed? Yeah, can someone explain the difference between them, velocity and speed? Great, awesome. Yeah, so one way to put it is that speed doesn't have a direction, velocity does. When velocity is negative, which way is it going? What if our velocity is negative? Left is correct. Yeah, we'll be going to the left. Positive, you're going to the right. And now I put velocity and speed here, and they do stand for derivatives in some cases, but in other cases they could stand for integrals, and we'll get into that a little bit later. Lastly, just again to review, we've gone over this a little bit, but what types of problems will you have to interpret a derivative for? It's mostly going to be free response questions. Sometimes you'll be asked to interpret the meaning, or other times it'll just be helpful to know what it means in order to work through the problem, because the better you understand what you're looking for, the better you'll be able to work through the problem. And that's, again, velocity or speed. When you're looking for velocity or speed, it's important to know what do I have? How do I get to velocity from what I have? Okay, so let's go and do the same thing now with integrals. So this won't look too much different, but still good to go over as well. Okay, so what does it mean to interpret an integral? Well, it means the same thing as interpreting a derivative, just to understand it in context of the problem. Then we want to make sure that we really understand the words that are commonly associated with integral. So can you guys give me some words that are commonly associated with an integral? Area, great. What else? Antiderivative, awesome. How about more anti-slope? That's an interesting one. I never thought of it that way. Distance, great. Yeah, so what's some other applied words you might hear? So we know slope, or anti-slope, sorry, we know area. What's something, distance is a great one to think about. What else do we know besides distance that an integral can help us find? Position, population, great, sum, volume. What about what goes with distance? What's the other one we always talk about? Distance and displacement. Great, awesome. Okay. And can someone tell me the difference between distance and displacement? Awesome, okay. Yeah, so distance, if you think about it, the way I explain this, I always use a track in running around a track. So your distance tells you how far you've ran, while your displacement tells you how far you are from where you started. Okay, so your distance is usually, depending on what you're doing, could be bigger than your displacement, because your distance is taking whatever way you moved, whether that be positive or negative, and it's saying this is how much I've moved, so I'm counting it as a positive. Whereas displacement, you could have gone all the way around the track, but if you ended where you started, your displacement would be 0, whereas your distance would be 400 meters. Okay, any questions on that, distance versus displacement? Net area, yes. So your net area, what do you mean by net area? Is that a term that you've used in your classroom? I hadn't really called it that. Do you mean total area? So total area and displacement are pretty much the same thing. Net area I can look into more for you. But yeah, the total area including negative, that's what the distance is telling you. Yep, exactly. Okay, great. Okay, and then just again, what types of problems will you have to interpret, that should say an integral for? Mostly, again, free response questions and some multiple choice questions, but we're going to focus on free response today because we don't know the setup of the exam. And if we can interpret them in context, then we can interpret them in a free response question or a multiple choice question. Okay, so now we've talked about how, especially velocity, if you think about velocity has, in some cases, can be a derivative that you're finding, and in other cases can be an integral. Okay, I've heard a couple of students say it's all free response questions. I hadn't heard that. That might have been a detail that I missed on the page, but I can definitely look into that for you. I think by April 3rd, we will all know better. So let's keep working on the interpreting in the context of the problem. So some of these words are words that you would see within any kind of problem. And they help you have a context here. Okay, so the first one here is more just in context of a graph, slope. If it's asking you to find something that's parallel, you know we're looking for the same slope. If it's asking you to find the tangent line, you know you need the slope to find the tangent line. If it's asking you to say it's asking for the normal curve, that means the perpendicular curve. So make sure that you understand if you see the word normal, that means perpendicular. And so those are just some ways you could see it in the context of a graph or in any kind of problem. But then we also need to make sure we can apply that to different situations, more in context situations, such as position, and distance and displacement, velocity and speed, and acceleration. And again, depending on where you are, so for example, if you're looking for velocity and they've given you position, do you need a derivative or an integral? So if you're looking for velocity and they've given you the position, you have the position. Good, derivative. Yeah, so derivative, if you're given position and you find the derivative of that, you will find the velocity. It looks like Maria looked in the AP Central and saw that it does say that students take a 45-minute online free response exam at home. So it says free response. So good thing we're going over free response tonight, because it sounds like it's mostly going to be free response. And we'll keep going knowing that it's mostly going to be a free response. But yes, if you have position, you have to find the derivative. And what if you have acceleration? If you have acceleration and they ask you to find velocity, you need to take the integral. Good. Okay. So it's important that we know that depending on what we have, we might need a derivative or an integral to solve the problem. Okay. But this also can work with graphs. So increasing and decreasing, maximum or minimum, or inflection points and concavity, all things that will involve derivatives and integrals based on what you're given. And then again, amount, accumulation, rate of change. Rate of change. What am I talking about when I say the rate of change? What does that stand for? The second derivative. So higher order derivatives are things we have to be ready for too. Exactly. Okay, awesome. Okay, so now how do you explain, if you're in a free response question, how do you go about actually explaining or interpreting it? What do you need to include in your interpretation in general? Awesome, units. Yeah, so what goes into our explanation? We definitely need units. Sometimes that can be a nice, easy point on a free response question, so never forget units. Even if you think the answer might be wrong, put the units on it. So what it means in context, good. So you need to look at the situation and interpret, are you taking a derivative or an integral? If you're taking a derivative, you're usually going to be using maybe the word rate. If you're taking an integral, you're probably going to be talking about an amount. Yes, you're definitely going to need to state theorems if you need it. I'm not sure in the interpret questions if you will need any theorems, but there's a chance. You never know. AP comes up with new problems every day. So again, units. You might want to include direction. So if you're talking about velocity or you're talking about a rate of something and it's negative, you need to make sure you include that it's decreasing. And then again, in context, as you guys said, it needs to be a description of what the problem was asking about. Okay, so let's try a simple problem before we dive into the free response questions. Okay, so the function t equals g of a models the time in hours for a chemical reaction to occur as a function of the amount measured in liters. What are the units of g double prime of a? Okay, be careful with this one. This one might be a little trickier than it seems. Take a second. What would be the units? Make sure you know what the y value is here. Okay, we've got some good answers here. Let's look at it. So it's actually hours per liter squared because of the way it presented the problem to you. Okay, so if it tells you the function is t equals g of a, models the time is what's they're talking about as the main part of the function. So it's hours per liter, hours per liter squared. Okay, we're used to seeing time as being the variable that's being plugged in. In this case, they told us t was what our function stood for. So that's something that AP is looking for you guys to pay close attention. It seems like a simple problem, but you've got to make sure you're reading in context. What is my y value? What is my, or even better, my independent or my dependent variable? So make sure you're looking for that. Okay, so one more time to go through it. Because it's time equals the amount and it's a function of time, the time is what goes on kind of the top of the ratio of the rate between what's happening in the time. Okay, so it's the time per liter because we're talking about a function in terms of time instead of the liters per time. We're really used to having time in the denominator. Liters is squared because it's the second derivative, g double prime. So since it's asking for g double prime, we've taken the derivative twice, so we have per liter, or per liter squared. Since liters is the independent variable. So since liters is the independent variable, it's on the bottom. The function is meant to tell you how many hours, so you start with hours on the top. Okay? Okay, let's try another one. Okay. The rate at which the depth of the water in the pool is rising is given by the function s prime, where s prime of t is measured in feet per hour. Okay, so now we're back to t being our independent variable. We are plugging in the time. Okay, so using correct units, explain the meaning of s double prime of 5 in the context of the problem. Now, it's important here that you're actually interpreting what does the 5 mean. Make sure the 5 is included in your explanation, or you haven't explicitly explained this part of the problem. So what's the meaning of s double prime of 5? Okay, feet per hour squared. Good, awesome. When the depth is 5 feet. So let's rethink about this, though. Where is the 5 plugged in? Good. Okay. So t is 5. That means that the 5 is how many hours. So after 5 hours, that's what's happening. The rate at which the pool's water level is rising, the rate of increase. Okay. Since it's a second derivative, usually when you're talking about a second derivative, you're talking about a rate of increase. And that's one of the best ways to describe it, because if increasing is already a rate. So if you say the rate of increase, you're accounting for the second derivative. Okay. How about for part B? I'll put up both answers in a second, but for part B, using correct units, explain the meaning of s of t in the context of the problem. So now this is more in general. Yes, for part A, it would be the rate of the rate. So if you say a rate of increase, that is already a rate of a rate, because increasing is a rate. Okay, what do we think about s of t? In the context of this problem, what does s of t stand for? Okay, good. So I'm going to challenge you guys. Those answers are all good. It is the amount of water in the pool. Make sure you're accounting for both variables when you're giving your answer. Okay, so s of t is telling you the amount of water in the pool. What did that t tell you? Why is the t there? Good, at time t. That's all you have to add on. That helps you have a more complete answer, and it shows that you understand where both variables are coming from. Okay. I didn't even put t in my answer, but I should have. But yeah, you would say at any given time t, and t is the number of hours. Okay, any questions on these two? Okay, you guys are doing great so far. What we're going to do now is we're going to dive into some free response questions, okay? So I've got bit paper open. Is there a Calc BC live stream tonight? Not that I know of. I believe it's just AB, but this will be covered in the BC exam. So if you want to stick around, this is material you will need to know anyway. But if you feel good about it, then that's good. Actually, let's look. That was C and D. Let's start with A and B. A little bit bigger, yeah. Okay. Okay, so we've got a table here, and we're talking about a zoo, and this is from the 2010 AP free response question. So again, if you wanted to look this up, you can look it up and follow along. But we've got a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, and then it says t equals 0. So what does that tell you? If it says noon is t equals 0. Time. And what is time 0? Time 0 is noon. Okay, so it's telling you to count 12 o'clock, not as 12 when you put it in the problem, but as 0. Okay, and then 8 p.m. is 8. The number of entries in the box, t hours after noon, is modeled by a differentiable function e from 0 to 8. 0 to 8 is for t. Values of e of t in hundreds of entries. Okay, don't forget that, hundreds of entries at various times t are shown in the table above. Okay, so I reworded part A to make it a little bit more of what we need to go over tonight, because part A kind of had the interpretation in the problem. So here's a rewording of it, but it's kind of essentially exactly what it was asking on the exam before. But we're going to use the data in the table to approximate e prime of 6, show the computations that lead to your answer, and explain what e prime of 6 stands for in the context of the problem. Okay, so we've got some calculus to do, and then we've got some explanation to do. So why don't you guys take a second and work on it? If you were with me earlier today, then this should be a nice, good refresher for what we did earlier. How do we want to start part A? Okay, so let's look at this. We've got e of t and t, and it wants us to find e prime of 6, right? Okay. Okay, so we've got a good entry here. Awesome. Yes, we just have to use the slope formula because all we have is a table. We can use the average rate of change. So we look at 6, well, we've got 5 and we've got 7. So we don't have 6, but we have the numbers on either side of them. So if we just use the formula we know for slope or average rate of change, we can use e of 7 minus e of 5 over 7 minus 5, which is 21 minus 13 over 7 minus 5. We get 8 over 2, which is 4. Okay, so we have 4. Oh, awesome. We have a great explanation here. So at 6 p.m., the rate at which the elephants are being deposited is 400 elephants per second. Okay, so the elephants per second we do need to work on because it's not exactly elephants, but we're entering names, and it is in terms of hours. Yes, so the units are things we've got to work on. In context of the problem, they're calling it entries. So we want to make sure we're staying consistent with what AP has called it. So this is in hundreds of entries. Okay, so this is 400, and then it's going to be entries. And we're going by T is in hours, entries per hour. Okay, so that would be a good complete answer for that one, up to the computations that lead to your answer. But we need to go a little bit further and explain Perla, I think you could do that. I think you could say 400 entries per hour. I think you could. So in this case, because you're only given a table and it says use the table to approximate. So I'm answering the question of how do we know if it's average or instantaneous? Normally we would want this to be instantaneous, but because we only have a table, that's all we have to use. And so it tells us use the data table to approximate. So this 400 is actually really just as close as we could get to what we want, average or instantaneous. So we have to use average in this case because we're given a table. Usually if it says estimate and it's talking about a table, you're going to end up using the average formula. Okay, so 400 entries per hour. And this is, we want to make sure, yes, at 6 p.m. At 6 p.m., that is the entries per hour. That's how many entries they're getting. That's a lot of entries per hour. Okay, let's look at part B. Use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8 times the integral from 0 to 8 of et dt. And then using correct units, explain what that means, that integral in terms of the number of entries. So for AB, this is the trapezoidal sum part is still in the test. But what the 1/8 is doing to our integral is no longer on your test. So I'm going to turn to the BC students right now because this is still on your test. And what does it mean? Let's start with explaining the meaning of this in the context of the problem. What does it mean that we've got 1/8 times the integral from 0 to 8 of e of t dt? What is that integral going to tell us? Good. That's going to be the average value of e of t. That's why we've got that 1/8 there. In terms of how do you do a trapezoidal sum, we will go over that. We'll do this problem out so you guys can see that. Okay. So, but in terms of the trapezoidal sum, I'm just going to go over the integral. So the integral from 0 to 8 of e of t dt, just so we can see something that's going to apply on every test. If we divide it by 8, we get the average value, and that's something that will still be on BC. Okay. So we've got our table here still. So what I'm going to do for the trapezoidal sum is start by actually just drawing out really rough sketch of what this looks like. Okay. So we've got a point at 0, 0. We've got a point at 2, 4. A point at 5, 13. I'm going to have to scale this a little bit more because it's not going to fit on this. We'll put 4 down here. We'll put 13 right here. This isn't going to look exactly scaled right, but we've got some limited space. And this is just for help anyway. We've got 7 and 21. This will be over here. And we've got 8 and 23. And that's pretty close here. 23 is going to be right here. Okay, so a trapezoid, if you remember the shape of a trapezoid, it's usually something along the lines of this, where these sides are considered the bases, okay? And this is your height. So what we're doing with trapezoidal sums is instead of drawing rectangles like Riemann sums, we're drawing trapezoids, and we're using the trapezoid area formula in order to get an estimate for what the area under the curve would be, or what our integral would be. So our area formula for a trapezoid, area of trap, is base 1 plus base 2 divided by 2 times the height. So in this case, in the case of our graph, our trapezoids are actually sideways. So our bases are our heights on the side here. So like this, if we were talking about this trapezoid right here, we could call this one base 1 and this one base 2. Okay, base 2 right here. And we're just thinking of the height as this distance, our change in x here. So we've got This is our h, our change in x. Okay. So the first one is kind of nice because it's actually just a triangle, but we can still use the trapezoidal sum formula for practice. Okay, so we've got base 1 is going to be what? What is base 1 of this first trapezoid here? Yeah, 0 right here. And then base 2, sorry, I should have redrawn this. I forgot to redraw that, but base 2 is going to be at 4. Okay, so we've got base 1 is 0 plus base 2 is 4 over 2 times the height. So from 0 to 2, our height is going to be 2. Okay, and that's our first trapezoid. Plus, now we move over to here. So base 1 and base 2, doesn't really matter which is which because we're just adding them together. We've got 13 and 4. So 4 plus 13 over 2. And what's our height this time? 3. Awesome. Okay, and then we'll keep going with this. Here's our trapezoid. 13 plus 21 divided by 2. And the height here is going to be 2. And then we've got one more here, one more trapezoid. And again, this is 23. So we've got base 1 is 21 plus 23 divided by 2 times our height this time is just 1. So this together should approximate the integral from 0 to 8 of e of t dt. That's our area under the curve. Okay, so what does that stand for, e of t, the integral from e of t from 0 to 8? Okay, awesome, 85.5. So the average number of entries. So let's talk about that. So if this is the trapezoidal sum, and what this would entail would be just the number of entries between 12 and 8, like you said. And then you could calculate that number. Again, in a free response question on the written exam, you're usually allowed to leave it out like this without having to do the math. I'm not sure if you would be allowed to on the new setup, so we're going to have to wait and find out. So our number of entries between 12 and 8. Okay. Yes, so this original problem, the original problem we were doing is an average value problem. And if you're taking the BC exam, you still need to know what that is. So the difference between that and this one is that we would just take this whole thing here and we would multiply it. Let me write it in a different color so we know it's different. We would multiply it by 1 over 8. Okay, and if we were to interpret that, we would say this is the average number of entries between 12 p.m. and 8 p.m. Okay. Any questions? Okay, let's move on to the next two sections of this problem. Make this bigger for you. Okay, so the beginning part's the same. We haven't changed anything there. It's still about the zoo. Now we're on parts C and D. Okay, so at 8 p.m., volunteers began to process the entries, and they process them at this rate P, where P of t is t cubed minus 10t squared plus 298t minus 976 hundreds of entries per hour of t on the interval 8 to 12. According to the model, how many entries had not yet been processed by midnight? How do we approach this problem? How do we find out how many entries need to be processed? Yes, we are going to need integrals, right? Because they gave us a rate. Okay, so they said P is a rate. I like the general statement, E of t minus P of t, but we want to get a little more specific. How many entries did they start with? Sorry, not how many entries did they start with. When they started processing the entries, what is the total number of entries that they had at the beginning? 23. Yes, good. So 23, they've collected 2,300 entries. Good. And so that's how many entries they have total. And it's asking us, according to the model, how many entries had not yet been processed. Okay, so we've got 2,300, which we're going to write as 23 for now because we're doing everything in terms of hundreds per hour. And then when we interpret the answer, we'll go back to that. We've got 23, and how are we going to figure out how many we haven't processed? Okay, we're getting closer. 23 minus P of 12. P of 12 is close, but what is 12? If we're talking about t. So we want to look at the problem. It tells us hour of t on the interval 8 to 12. Okay. So what we've got here is we've got 2,300 total entries. So that's 23 minus however many entries they were able to process between 8 p.m. and 12 a.m. of P of t. Okay, so we've got to take an integral from 8 to 12 for P of t. And then we're going to take 2,300, which was our total, and subtract that from it. Okay, so now, again, remember I said this problem is a calculator question. We could definitely find this derivative by hand, or sorry, this integral by hand if we wanted to, but you can absolutely just plug this into your calculator, plugging in P of t, and solve for it. Why do we take the integral? So P of t is a rate. So the integral from 8 to 12 of P of t is going to tell us the number of entries processed between 8 and 12. That's supposed to be an and sign. It's harder on this computer. 8 and 12. Okay. And so it's the number of entries processed between 8 and 12. So since we've started with a rate, if we integrate it, we find the amount. We find exactly how much has been processed during that time. Okay. So when we take this integral, has anyone taken it on their calculators? I ended up with 16. 23 minus 16, which gets us 7. Okay, so if you type this integral into your calculator, this integral here, plugging in P of t, which is t cubed minus 10t squared plus 298t minus 976. If you plug that into your calculator with this integral, you should be able to get 16. Yes, if it was done by hand, you'd have to take the antiderivative, which we could definitely do of this. It would just be big numbers and messy. But we can do that for practice right now. Not plugging in 8 and 12, but just taking the integral of t cubed minus 10t squared plus 298t minus 976. Okay, so that integral is going to be, do we have it? Yeah, so on the exam, normally this would be a calculator question, but we haven't been told how much of the exam is calculator or non-calculator. So that'll come with time, April 3rd. So this would be t to the 4th over 4 minus 10t cubed over 3 plus 298t squared over 2. 2 minus 976t. And then you would want to evaluate that from 8 to 12. So what AP has said about the exam is that they have made it so that the questions, you shouldn't be able to, because it's online and they know that you have access to resources, the questions that they are using in the time they're giving you, you shouldn't be able to use too many resources. It really is more just your brain and what you've learned. And sometimes the calculator can help with that. That's fine. But they're not going to give you questions that are going to be so simple that you can just plug them into the calculator. But there may be calculator questions. So I got 7. So we're asking when I plugged in the integral, when you plug this in, you should end up with 16. But since this is a calculator question, we don't really need to do it out by hand. And so 23 minus 16, we get 7. But what does that mean? What does that 7 mean? Perla, did you plug it into your calculator and get a different number? Or did you do it out? Okay, yeah, it might be something to check. Make sure you're using the correct bounds. And if you have a TI-84, you're probably plugging in X, and make sure you do it according to DX. Yes, okay, Madison, great. So 700 entries are not yet processed at midnight. That's exactly right. Okay, so now let's look at part D if we're ready to go to that. It says, according to the model in part C, so it's probably talking about P here. This is our model. And it says, according to that model, at what time are the entries being processed most quickly? What are we looking for most quickly? Awesome, a maximum. And Talia hit it. How do we find a maximum? We find the derivative or the slope. And once we find that, we can find its critical points and find the maximum. Okay, so let's start by finding P prime of t. So this is part D. And P prime of t is going to be 3t squared minus 20t plus 298. Okay, there's our P of t. And we want to know when that equals 0. Now, again, we've got a calculator question here. So how can we find out when this equals 0 without having to do this out by hand? How can we use our calculator to find where it's going to equal 0? Good. I was thinking what Talia said and graph it. You should be able to graph that without getting a complex number. So if you type into your calculator in the graphing section, 3t squared minus 20t plus 298, and then you look for the zeros on the graph, you will find those values. So you should get t equals, I have two values, 9.184 or 5, and t equals 10.816. Did you guys get those? Anyone able to try that on your calculator? Actually, you know what? We can try it in Desmos. So let's go over here. P, or actually let's just use y equals because we're typing the derivative. Okay, did we do something wrong here? I am also getting, it's this plus 298. So what did we do wrong? Do we have any suggestions? Let me take a look at the answer just to check our work. Oh, I know what the problem is here, you guys. Actually, this was my fault. Okay, so let's come back to the problem. And Perla, this is probably why yours didn't work right. I actually copied the problem down wrong. It is 30, not 10. So let's take a look at that. Okay, so this problem, when I rewrote it, I rewrote this wrong. This should be 30. So let's go down here and let's rewrite this before it gets too messy. So we've got P of t equals t cubed minus 30t squared plus 298t minus, let me just check, minus 976. So that's why. That's going to change our answer. Okay. So that may solve your problems if you weren't able to get the right answer last time. Sorry, my fault. I need to check my work when I rewrite it. I just needed it to be clearer on the screen for you guys. So now let's find p prime of t again. We get 3t squared minus 60t plus 298. How does that do? Okay, good. It looks like we've got it now. Okay, so I use Desmos to graph it just so I can show you guys. And when we're at this point, we can just look for the zeros. So if we look at our zeros here, we've got 9.184 and 10.816. And it's good that Desmos rounded to 3 decimal places because we need 3 decimal places. So we've got t equals 9.184 and t equals 10.816. Now that we've got those, let's get you back to the problem. Okay, and what do we do with those? So let's go back. It asked us for the time when they were being processed the fastest, and you guys told me we needed to find the maximum. Okay, so if we took the slope, we set it equal to 0. Okay, good. So actually interpreting the graph can help us with that. So we know that the graph of the derivative went like this. Okay, so if the graph of the derivative did this, we can tell which of these points is going to be a maximum and which of them is going to be a minimum. Okay, which of those points has the possibility of being a maximum value? Yeah, the left one here, right? Because we're going from positive to negative on P prime here, which means that we went from, on P, we went from increasing to decreasing. So that would be a max. But right now, we can't really be sure that that's exactly what we want. And what else do we have to take into account that will help us be sure that 9.184 would be endpoints? Great, thank you. Okay, so this is an absolute maximum because we've got a set value. And what are our endpoints right now? We've got 9.184. What else do we have? 8 and 12. 8 and 12. Awesome. So now we've got these 3 different values, and we want to figure out which one of these has the highest value or the highest rate that P would be moving at to say that we were processing the most amount of entries at that time. Okay, so what are we going to do? We want to make sure we're plugging in these values into P of t, right? So if we plug each of these into P of t, we plug in 8, we're going to end up with 0. We plug in 9.184, you should get about 5.809, about that, or 0.89. Yeah, good, Madison. We're going to plug in, see which one is greatest. And then for the last one, we plug in 12. When we plug in 12, we get 8. So when you're looking for a maximum value, you take the value that you found in P prime and then you plug it into the original problem, because maximums are coming from a value from the original problem or the original function. P prime would tell you if it's positive or negative, and it would tell you if it was increasing or decreasing. Yeah, P is a rate. Good. Okay, so we've got 0, 5.089, and 8, and it's a good thing we tested the endpoints because it looks like 12 has the fastest time here, okay? So, or the fastest rate. So again, in terms of interpreting, what does that mean? T equals 12. This should say P of T equals 8. I should be a little bit more accurate with my writing here. Make sure you guys know. Or this is P of 8. This is P of 9.184. And this is P of 12. Okay, so P of 12 is the greatest. And what does that mean? Yeah, so at midnight, they were processing the entries at a rate of what? How many entries were they processing? We've got 8 here. Good, 800. 800 entries per hour. Okay, great. Awesome. So that is the time it was fastest. So as you can see, only one part of this problem, let's just go back here. Only one part of this problem asked you to interpret. But in order to write the answer down for the rest of the problems and explain your reasoning, you needed to include work and you needed to show that you understood how to interpret it in the context of the problem anyway. Do you include all work for the FRQs? Yes, you should include all of your work. The way that AP distributes points for free response questions is your work counts as part of the points. So even if you got the right answer, so for part D, if you just put 800, which is technically the correct answer, you probably would not get full credit for that problem. They would want to see that you understood and you tested the endpoints. So usually when they're asking about a max or min problem, they'll give you a point for remembering to test the endpoints. And here you wouldn't even have been able to get the right answer if you didn't test the endpoints. But if you did it in your head and didn't write it down to see that they knew you should test the endpoints, then you wouldn't get full credit. So free response questions, you really should just write down exactly what you're thinking in your brain step by step, and use that as kind of a guide to help you get to the answer, because then they'll be able to see that you understand how you got to the answer. Okay, and then remember that question we went over earlier where it was written as a function of T equals and it was hours per liter. So don't forget to read the question really carefully when you're interpreting. But it's really important to just think to yourself with every problem, what do I have and what are they asking me to find? And if you can ask yourself those two questions, you can interpret if you need a derivative or an integral, and then you can use the context of the problem in order to help you understand, are you looking at a rate or are you looking at an amount? And so how should I label that? Are there any last questions before we sign off for the night? Okay, awesome. You guys did great tonight. Thank you for your help and your participation. It helped so much. I hope that you guys got something out of this lesson. Be sure to stay tuned and come back. More streams on how to do free response questions. Absolutely. We can do a general free response question stream. Yeah, no problem. Okay, thank you guys. Have a great night. Good luck studying.